So in this problem, it states a sound wave with intensity 2.0 times 10 to the negative 3 watts over meter per squared is perceived to be modestly loud. Your eardrum is 6 millimeters in diameter. How much energy will be transferred to your eardrum while listening to this sound for 1 minute? So in this problem, we're trying to find energy. So what we could do, we could just circle energy. We're given values here. So we're building intensity, which is this 2.0 times 10 to the negative 3 watts per meter per squared. We also know that the eardrum is 6 millimeters in diameter. And then we also know the timing, which is approximately 1 minute. So the way how we approach this problem, it's write whatever it's given values. So in this case, we're given energy, which is pressure times time. Power times time. Yeah. We also know that intensity equals to P over A, where A in this case, since this is eardrum is circular, we know that area is equal to pi r squared. This is because this is the area of a circle. We also know that if we're able to derive this expression here, we could have it I equals A is equal to P, in which we could plug it into this equation as well here. So we could rewrite this, so E equals to PT, but now we're going to add the I times the A times T, energy, because that's going to how much energy do we need. So our next step, it's also deriving this area here, so I is equal to pi times radius squared times T. So in this equation, we've given a lot of values, but one thing we're missing is radius from the area circle, because we're given diameter. So the way how we're going to figure it out is, we know that diameter is equal to radius over 2. Radius is equal to diameter over 2. So then what we could do is 6 millimeters over 2 is equal to 3 millimeters. But since we want our units to be consistent, before solving this problem out, we need to write what also what's given in our units was also given. So we're given intensity, which is 2.0 times 10 to the negative 3 watts over meter per squared. Diameter is equal to 6 millimeters. Energy, we're trying to figure that out, and time, which is 1 minute. So we have our values here. Now what we could do, we could plug it in here, and so this is, and we convert this into meters, we get 0.003 meters. So now all we gotta do is just plug in our numbers and we could find energy. So the way how we're gonna plug it in, so we go I, which is 2.0 times 10 to the negative 3 watts per meter squared times your area, which is pi times 0.003 millimeters squared times time, which is 1 minute. But since we know 1 minute is also in seconds, we can convert this into 60 seconds. And the reason why we're doing this per seconds is because our energy is joules over per second. If you recall the formula, that is E equals to over T, in which E is joules and time is equal to seconds. So at the end of our problem, at the end of this, we want our units to be consistent. So yeah, because if we convert this, P over T equals to E, our answer has to be in joules, and this is in seconds, and this is just the power units. And so we solved this out, and then we got an answer of 3.4 times 10 to the negative 6 joules. And that's our final answer.